Our last physical talk and presentation for today is by Brydon Timothy Wang, who's had a very busy week. He's just joined the QT Faculty of Business and Law as a lecturer, so congratulations on your new appointment. And he also has a newly published edited collection, Automating Cities, Design, Construction, Operation, Future Impact. We've had a lot of discussion today about makers and makerspaces and maker communities. Brydon is going to take us one step further and talk about maker cities and FAB cities and robot cities and smart cities. Brydon.
Thank you. Okay. Thanks for the introduction, Matthew. Right, I'm Brydon, and welcome to the machine Metropolis. So what I want to do today is just pick up some of the key learnings from an edited collection that we published 3 weeks ago. It's called Automating Cities, Design, Construction, Operation, and Future Impact. And the book basically covers how we take in automated city systems and apply it in cities, and the impact these systems then have on the way we live. And the technologies sort of surveyed in the book cover, city apps, robots that operate buildings and fabricate structural elements, 3D printing, drones, sensors, and automated decision-making systems. So the book basically came out in part from a small little section of my lit review. I was really excited about the technologies of automation that were being in place in the construction industry, and so I reached out to some of the designers, urban informatics professionals, architects, engineers, and legal professions. And basically what happened was, as the chapters started coming in early last year, there was a very consistent message that was actually showing across a lot of the chapters. And it's really about, as we embrace these technologies of automation, as we design robots, as we deploy sensors and automated decision-making systems, we really need to consider how these technologies engage with and respond to the complexity of human behavior and needs. So the way I want to sort of structure this presentation, it's going to be less of a deep dive, more of a sort of a quick review of some of the stuff that was explored in the book. I want to explore the two dimensions of automation in the city. So really the mechanization of the city through robots, the automation of prefabrication and modular construction, and then really the other aspect of automation, which is the digitisation and datafication of the city. And then the last part of the presentation, I'll be sort of looking at asking this question: how are we taking these technologies and responding to complex human needs and behaviors? So what I wanted to do is start off with this picture. So exactly a year ago to this day, China was embarking on a very ambitious project, or two very ambitious projects. They were building the 1,000-bed Huoshanshan Hospital and the 1,600-bed Leishanshan Hospital. And of course, the Chinese have a very unique labor environment that allows them to sort of rapidly deliver infrastructure to service urban needs, particularly in a pandemic. But what is really unique about it is that these kind of timeframes are not possible if they didn't have technologies of automation in modular and prefabrication construction. So automation in the city is really not a novel occurrence. Historically, we've had lamp lighters that have been replaced as we electrify our street lighting. We have had lift attendants that are now sort of replaced with automated lifts. We're very comfortable in sort of stepping in, pressing a button, and it'll take us to our floor. And then we've got cars now with varying levels of automation. We also now have robots that interact with us and provide us with information, help us build and construct things. And we've got 3D printing and various kind of other technologies that help us to sort of change the way we consume goods and services and the way we live our lives. Now, in terms of mechanization of cities, we've had robots for quite a while. So my son and I were sort of in a pool over the weekend, and he doesn't quite like the pool robot. And I'm like, but the pool robot is so cool because this was really the first instance of robots in a domestic setting. So the first domestic robots were these pool robots, and they came to us in the 1960s. And generally, they're pretty smart back then already. They were mobile and autonomous in that they could sort of roam around the pool, they could filter water, and they knew when you'd taken them out of the pool. But it took us another 35 years before these robots were actually then brought into the house to do domestic tasks like sweep the floor. And the reason for that is because designers were really quite challenged by having a robot interact with a full spectrum of human behavior. It's very complex. So back then, the thinking was really robots needed to operate in a safe space away from complex human behaviors. And so if the robot wasn't in the pool, where could we put it? And so we had people think about how we could put robots on the side of buildings, so outside of our living spaces, where they would have this hypothetical swarm of robots called edge monkeys that would patrol building facades, operate windows, window blinds, and mechanical vents. And in that way, help us interact with the outside. So the building itself would become a machine interface that we would interact with. Now in the book, there's one of the chapters that covers kinetic screens, and it's by Joseph Lim, and he explores the automation of an origami fold in this particular sort of kinetic facade. Now, right now, the thinking has shifted. We're really looking at bringing robots out of very sterile environments and into the construction site. So in the book, there's a really nice chapter by Dan Luo and Lei Yu who explore industrial robots and how we can bring them out of the factory into construction. And unlike their predecessors that were designed for sort of single functions, industrial robots nowadays are open-end customizable platforms. And that means that they're able to respond very quickly to what's happening on site. They're a lot more flexible and they're able to engage across a range of human behaviors. But this responsiveness is also changing the way we conduct construction on site. So typically, she provides a couple of different projects. And some of her projects really are about robots that are building structural elements in the construction process. And as it builds, it then reassesses how that structural element is performing on site, and then it returns back into the design phase. So instead of a normal construction process where you design first and then you construct, she has now asserted that the way robots are going to change the way we construct is that we'll have both systems running in parallel. We'll have a bit of a design, a bit of construction, and then you'll just circulate between the two until you actually end up with a beautiful product. The desire for responsiveness is also changing our engagement with technologies of automation in the builder and maker scales. So just as we had that journey of the pool robot out of the pool and into our homes, just as we had that journey from industrial robots out of factory settings and into the construction industry, we're having the same journey happen in the makerspace community, where we're looking at technologies of automation and seeing how they respond to human life and how we reconceptualize the way we consume goods and services, design and live our lives. Now, technologies of automation have always provided a way for us to conceive of new versions of the city. So in the 1960s and 70s, we had the UK group Archigram and the Japanese Metropolis come up with really, really interesting visions of the city based on sort of futuristic visions of what technologies of automation could be. So here we have a sort of a conceptualization, a modern day conceptualization of Ron Harron's walking city. So the idea would be certain components of the city would be able to move around and travel. We also had Peter Cook's plug-in city. And Peter Cook's idea was basically we'd have these superstructures with a crane on them. And you would have these modules that were programmed for different services that would then be brought in and plugged into this superstructure. Now, this idea actually then has come back to us in the form of FAB Labs' recently abandoned Quayside project at Waterfront Toronto. So the idea here was also to have cranes that are embedded within the urban development that would then be able to plug and play different kinds of modules that provide different services. Now, despite this project not getting off the ground, we see the same idea again being repeated in Google's proposed new campus for Mountain View. Now here, the idea here is that we would have a massive big tent, and then we'd have different sort of modules that are programmed with different structures that would then be moved around the internal space of the tent by crabots, which are crane robot hybrids. And so in this space, they want to sort of hack the space so that the space becomes responsive to whatever services or functions that we require of it. Automation in prefabrication and modular construction is also allowing us to make similar reconceptions of the city. So in the book, there are two chapters that explore this. The first is by Richard Liu and Y.S. Chua, and they examine the use of design and automation to really increase our ability to build high-rise buildings in a modular way and create spaces internally with greater internal spans, and that's really required for industrial applications in factories. The second chapter that I was quite excited about is the use of automation technology in modular construction of floating structures, and then different kinds of technologies of automation that are then used to assemble these floating structures in the water. And these are different possibilities that allow us to then reconceive of the city, create hybrid floating cities, and look to meet emerging urban needs. We're also, of course, seeing 3D printing being used to address urban challenges, and Matthew and I have written this chapter where we look at what's the status and progress of 3D printing on housing construction. And we examine this from a legal perspective where we look at the intellectual property activities like copyright, design law, patent law, and trademark, see what's happening in the dispute space, see what's been developed. And we look at then this 3D printed building or housing, how it interacts with building regulatory frameworks, so how materials that are used to print respond to industry standards, and the impact of 3D printing on work health and safety laws. But what we found, of course, is that we don't know enough about these systems to fully accept automation technologies in all aspects of our lives. So if we look at 3D printing of buildings, we don't know about the printing materials that are being used, how they perform over decades, how they're going to sort of weather, how do we fix defects that we find, what the implications are for statutory and contractual warranties. We have not also worked out how we sheet home liability in relation to designers and contractors when a 3D printer is used on site, because who actually has liability for this? We've also seen that advances in automation and prefab and modular construction still requires a highly skilled workforce. So that's the great news. Robots will not replace all of us. Liu and Chua observed that we still need manual labor. And the same observation was made by Dan Law, the one who brought industrial robots into construction sites. Now, this creates a potential for errors in fabrication. And sometimes, when you're sort of storing modules and trying to load them up, there's eccentric loading that can cause sort of problems as well. But this provides us with further opportunities for us to consider how these technologies of automation can be designed to respond to human behavior and the needs in the construction context. Because if you sort of cut out the human, you don't really need to configure these robots to deal with complex human behavior. It's only through this interaction that we actually get these interesting developments of how we can better produce robots. Now, at the city level, beyond the mechanization that I've been talking about, we've progressed to digitisation and datafication of urban life. We have 3D handheld scanners that we can sort of shake and bring on site that creates 3D models of buildings. We have drones with cameras that sort of hover around or over construction sites that are able to use a camera to sort of measure the progress of construction works or to conduct structural health monitoring. So we have two chapters that sort of look at different portions of how data is collected and then sort of assembled in common data environments, and then the machine learning techniques that are applied to the data in order for us to determine what's happening on site. But outside of the context of construction, the digitization of the city is now characterized by constant interactions between the occupant and the larger urban operating platform. So you think about it as a digital layer that sort of sits over the city, and the embedded robotics and algorithms that operate as city apps. So in the book, quite early on in the book, we have Martin Tomic and Marius Hugenmiller who suggest that because of this constant interaction with these city apps, we need to really look at human-centered design models. So we talk about participatory design, action research and design thinking, spiral models, service design systems thinking, and to use these models to guard against this knee-jerk technological optimism that erodes human-centered design. Because what we really don't want is to prioritize technological advancement over humans. And I think it's really timely that, sort of a few days ago, Tim Cook on International Data Privacy Day sort of made this really grand statement about what's been happening and how Apple's going to move in a very different direction to some of the other big tech companies. Technology does not need vast troves of personal data stitched together in order to succeed. If a business is built on misleading users, on data exploitation, on choices that are no choices at all, then it does not deserve our praise. It deserves reform. So he continues, we should not look away from the bigger picture. In a moment of rampant disinformation and conspiracy theories juiced by algorithms, we can no longer turn a blind eye to a theory of technology that says all engagement is good engagement. And that's quite key here. The longer, the better, and all with the goal of collecting as much data as possible. It is long past time to stop pretending that this approach doesn't come with a cost. A polarization of lost trust and, yes, of violence. And I just want to pick up on that last point about trust and trustworthiness. Responsiveness to the complexity of human life requires us to consider trustworthy systems to protect the privacy of urban occupants. So in the last three chapters of the book, we touch on digital representations of an urban occupant, where the third last chapter looks at decentralization of power through the blockchain as an example. The second last one looks at empowering urban occupants through data sovereignty. And the third and the last one, of course, I wrote this with Mark Brydon, and we really looked at how technologies of automation need to signal trustworthiness. So in the third last chapter, data collection was looked at to articulate the power imbalance between private and public users of collected data and occupants subjected to surveillance. Now, of course, because of the way we've now collecting data and the way we practice automated decision-making systems, surveillance is no longer centralized. We've now moved to a decentralized form of surveillance, and you use the blockchain as an example. Now, this, of course, results in a dispersed form of surveillance. And in particular, they look at how occupants engage in self-surveillance because of this dispersed surveillance, and how occupants adhere to the rules and standards of the community they impose on themselves. But what are these values that we impose on ourselves? How do we get these values? How do we assemble these? And how do we trust the data extraction processes that influence how we create these values and reinforce these data collection practices? Now, data collection is designed, implemented, and used by humans. So naturally, the subjective intent remains relevant even when expressed through a supposedly objective code. Now, in the second last chapter, Marcus Forth and his researchers really look at why we need data transparency, access, and education to enhance data literacy. They argue for a realignment of the surveillance relationship between data collectors and occupants, and suggest that we need city-based data hubs that would operate 4 different types of services. So they are, the first, a clinic with in-house data scientists that help the public understand what's happening with the data. The second, training facilities to host seminars like this, labs to engage occupants in shaping the digital offerings that are being provided to the city. And the last one is really a studio that would allow public, private, civic sector participants to come together and act as an evaluation panel to assess and direct the data future of the city. Now, in the chapter that I wrote with Mark Brydon, we really looked at digital twins, which are virtual models of the built environment. And these models allow city administrators to predict and drive desired behaviors without occupants being able to actually participate in a decision-making process. So basically, you collect the data, it goes through analysis, it pumps out a decision output, and all of this is automated and often in a black box scenario. And the problem with that is that some of the city administrators who use this data to make decisions don't actually know how the decision was actually created. It's blind on both sides. So what we argue for is that we now need to create seams in this decision-making process to enable an occupant in the city to exercise their right to the city. So in order to fully respond to complex human behavior and needs, we need to signal benevolence through seams in the decision-making process. We need transparency, all the different elements that are associated with that, contestability, explainability, and how we give value to the privacy of occupants becomes quite crucial. So I just want to end this summary of what's been happening in the book to say that as we continue to integrate technologies of automation in our cities, we need to consider the values that we will use to shape the design of these technologies, and how we then formulate these values in a benevolent way. So we argue, and many of us at the back of the book argue, that information privacy will be a core foundation of the future operation of trustworthy technology. All right. Thank you.